per capita wise, top 1% actually contributes 50%. Between top 10% will actually contribute most of it. And the contribution that comes per capita from the bottom 50%, you can't even read it. You can't even figure it out. And yet, who suffers when things like this happen? Most. Now, in India in particular, I want to point out that in 2010-21, 85% of the families, households in India had less than 25,000 rupees per month income. Most of us do not come from that background and therefore do not even understand that is it possible that 85% of Indian households have less than 25,000 rupees? And it is this section which gets most impacted. Last 3 days we were very worried. If one more day rain continued, this place would have been flooded. Chennai, and Chennai is the third largest city. But if it was flooded, even the people from high-rise building had to take boats to get out. What happens to the people with low income? And I think that's a very important thought that I should keep that in mind. And in fact, the strategy that we are going to evolve is also going to keep this in mind. In terms of emerging markets, contribute very little per capita. India is already only 103rd in terms of per capita terms. So I remember talking to the Prime Minister about 7 years back, says, is it an India problem? But actually, and in fact, per capita, as I point out, India actually contributes very little, very little. Most of the contributions come from countries like United States, Canada, other developed world. But do you realize that India is also, in terms of total GHG emission, we are already number 3? We are already number 3. Per capita, we may be very small. But if you add our 140 billion people, we are number 3. Of course, China is the largest, United States is next, and we are number 3. But what is more disturbing is that if you look at the last 20 years trend, 25-year trend, from 1991, as our GDP is growing, our contribution to the GHG emission, energy consumption is exponentially growing. And it's a matter of 10 years that we will even probably displace United States. So whether we like it or not, we are the most affected and we are amongst the most contributor. And we have to do something. And it is this that made IIT Madras Research Park about a year back, when our board came up with a 10x program, say, we will take the lead in India. I won't say we will take the lead. It will be our responsibility in working with others to see that India become among the top 3 or 4 countries fighting the climate change over the next decade. And this is what we started talking and working, and Anson came in and others came in, and we tied up with Rahul. And this is the beginning of that. Next year, I'm proposing that I want all the CSIR labs to be out here, because all the researchers have to work together with the industries and all the industries to be there. We have to take R&D all the way to commercialization, and that will be the message. I want to point out one more thing, that if I look at the population growth, now India's population growth is almost flattening. We are probably 1.4 today. We'll probably reach 1.55 and then start falling. Before the end of the century, this will happen, we'll start falling rapidly. Most Asia, that's what's happening. But Africa is growing very, very rapidly in population. And you will soon see that in terms of total contribution, they will become significant. What I'm pointing out, the technologies that we develop and deploy here is also going to help Africa. So actually we have to take leadership India has to, and India is in a unique position to take leadership and take emerging country like ours and Africa along with us. China will go on its own way. The developed countries will go on their own way. We need to take the leadership for the rest. And this is what I want our scientists to do. This is what I keep on asking our Satyar Seshadri and others to sort of say, we must do this. There is no question of the total consumption is to explode, and energy usage. So all these countries, Vietnam, China, we still are largely coal dominated, and we need to move away from that. And of course, in terms of, this is a very interesting graph, 100 most polluted cities in the country, in the world. And you see, 46 are in India, 42 are in China, and all of us know we are choking. And some of us in South India don't realize, actually, if you see Ghaziabad, Bulandshahr, Jabalpur, Bhiwandi, Noida, Greater Noida, Kanpur have become the worst polluting cities in the world. Lucknow, Delhi. North is even worse. And we do not have a choice but to move to fossil-free based transport. Before I elaborate, let me look at how I look at energy. What is the energy primarily used today? First was lightning. In fact, 25, 30 years back, lightning used to contribute very significantly to the total energy consumption of the world. Because we used to use tungsten bulb, something that we started using 150 years back, more than 100 years back. That's what we were using. And then came CFL, significantly cut down the energy consumption. And then came LED. LED came this decade. I remember when I went 2015-16 to join the government along with Piyush Goyal, we are just starting that. And today it is LED, LED, LED. As a result, lighting no longer contributes. Even though the amount of light that we use is much larger, lighting no longer contributes. This is something that we did not contribute. We were not anywhere in the R&D in this. We are now consumers, which is okay, fine. But there are two areas. Heating and cooling today dominates. Heating and cooling is a dominant energy. I'm not just talking about, for example, this research park, 40% of our energy is in cooling. And other parts heating. But not just that, even in homes, in industry, all the cooking that we do, washing machine, everything is heating and cooling. That is one area we want to become the leader in the world. In fact, that's the reason one of the sessions is heating and cooling. I think that's where we have to become the leader. India is a slightly warmer country. Heat is going to be a serious issue. If GDP increases, you saw the figures, the way refrigerators are rising. That is what we really need to somehow counter. Heating and cooling, we have to be. The second major usage is now motors. And it used to be engines, now it is all becoming electric motors. And they're highly inefficient. I'm not just talking about vehicles, but every industry just uses motors. Can we increase significantly the energy efficiency here? Can we again become the leader in the world? We have a Professor Kannan sitting somewhere here, and we really believe that these are the areas where we can become the leader, and we will like to do that. Then electronics. My own area, fortunately, the 12 volt became 5 volt to 3.7 volt to 3.2 volt to 2.8 volt to 2.4 and 1.7 volt today. Our energy consumption in electronics is not very large. But if you look at what is happening at the cloud, that's where the energy consumption is very large. And our usage of cloud is going on increasing. If you don't do something, that is going to contribute very significantly. But remember, there also, the primary energy consumption is in heating, cooling. So the heating and cooling that we are going to talk about is going to play a role there. Actually, I was quite surprised that one of the large industry in the country, one of the largest cloud company in the country, located in Chennai, switched from the air conditioners which use chilled water to air-based air conditioner. Why? Because there is not enough water for cooling. Can we not handle that as a technology? Can we not do something? We very often just try to follow what is being done in the West. My biggest concern is that many of the problems are our own, unique to India. And if we don't look at India and solve problems, we will not be able to solve many of these problems. And that's the reason I'm strongly suggesting institutes, academic institutes, CSIR lab, other labs, working together with industry to do that. Solar and wind is upon us, and the next session we'll talk more, and we have people like Sujoy, Milind out here who are trying to do everything to do that. Energy management will play a key role. Another major area, in fact, we had unfortunately, person who was supposed to come couldn't come for the inaugural. The person who's driving One World, One Sun. The only way this sun and wind, the fact that they are not 24/7 can be actually handled. One is through the storage, other is to have a large grid across the world. Can we really do this? Can we? And I thought that this is very, very difficult and will take a long time, till I heard that Australia and Singapore are trying to put an intercontinental electricity line under the sea and will be probably ready by 2030. I remember that I used to work in optical fiber, and the only way the world used to communicate with each other was through satellite. And in early 80s, nobody thought that there can be an alternative. And that's the time the talk started about putting optical fiber. Optical fiber was being put on the ground. I used to work in that area. There was no problem. Can we really put optical fiber under the sea? Can we really take power to all the repeaters that will be required? And it looked like an impossible problem in the 80s. 10 years down the line, we had done it. And 20 years down the line, in fact, we had so many optical fibers running all across the world that one couldn't even believe it. And actually, India became the leader in terms of, we acquired the Tyco stake and the stakes of Flag, and we became the leader. We have lost the leadership today, but can we take leadership in this one world, one grid and work on the technology? I'm very keen on working on the technology to even take the war. In fact, a small problem. Sri Lanka is suffering. You know, they don't have coal. All their power comes from oil. And their costs are very high. They are subsidizing, but their economy is getting killed. And in this recent crisis, we know what happened to Sri Lanka. Can we not take power to? India has enough, even coal power plant. I'm not saying coal power plant is a future. Can we not take that up as a challenge underwater? Can we find the economics for it? All that, we'll talk about it briefly. What can be the strategy to move all the world? Usage of energy, of course, we have already said electrification, push will be there, increase efficiency in heating and cooling will be there. Source of energy, we'll push it towards green. That's not the issue. What can be the strategies to net zero? And this is the point that I want to make. I want to put these 4 slides and also comment on what Kalai Selvi had mentioned. I strongly believe, and we did this in communication because that was our area, that there are 4 stages of any technology. The first stage is identify technology and do R&D and prepare, work in the lab, produce science, proving science. That's a stage 1. Where I can probably create with a new way even 100 watt hour of energy. That itself will be something substantial. That is a stage 1, which of course IIT does very well, some of the R&D labs does very well, but that is not enough. The next stage is the critical stage. Proving technological and economic viability. From that 100 watt hour storage that I produce in the lab, can I go to a gigawatt hour? Is it technically possible, first of all? Number 2, is it going to become economical? At 100 watt hour, I don't care. Will it give a return on investment? I think that's if we don't talk in terms of scientists at stage 2 do not talk about return on investment, they are going to fall. Nothing will actually happen. India's biggest problems at IITs, at CSIR labs, at all other labs has been our science sitting in stage 1, not moving to 2. The stage 2 does commercialization. You prove that it is scalable, prove that at scale it is commercially viable. And I think that's what the job of research park is for every technology and all the research parks, not just this. And that's the key work that we do. Then comes build market, initial implementation. Initial implementation is where some policy support is required because you're not starting at a scale. That's where some support is required, but and some financial incentives and policy support. And the fourth stage where is like solar today or wind today. We don't have to do any support. It is economically viable. It is cheaper to produce power from there than with coal. So I think every technology we have to figure out how to take it to this stage. If we are not able to take it to this stage, it's of very limited use in short term. 20 years, 30 years down the line, the work that I do, can it be useful? Maybe. I'm not dismissing that. But this we really need to do. And this is where some pre-commercial and R&D funds are required, some CSR and all. From here onwards, there are enough commercial funds. And again, something that Research Park has proved. We have to date incubated 290 companies out here in last 10 years, 11 years. The value of these companies today will be touching 50,000 crore rupees. We have invested hardly 3 to 4 crore rupees in all these companies together. And the value of the companies coming from here is close to 50,000 crore rupees. We have an official value of 33,000 crore rupees because our value is slightly older. But in the meantime, our companies are doing extremely well. That is because they are reaching these stages. And that is what, another thing that we have to do. And no, I agree with him, not at one place. And all this does not happen with engineers and scientists alone. If one has to get everyone, every section of society, not just social scientists, architects, every section of society will have to be involved. Strategy towards net zero is to drive each technology to return on investment. Very simple. Drive every technology such that it reaches return on investment. If there is return on investment, there is no shortage of money. If there is no return on investment, you can keep talking about, keep cribbing, keep begging here, there, you will not get anywhere. Your work is very incomplete till there is a return on investment. Even if it is 7-8%, I think it can begin. It can go over time. And that's where it's scale. Investment for transition, there are enough people. Our top 10%, remember I showed you the 85% have very low income. Our top 5% has enough money. And we can borrow money. Top 5% can borrow money. And today, if our money sits in the bank, it doesn't get much interest. As soon as we can get something higher than that, taking the risk factor into account, we are willing to shift the investment. And we can get investment. I don't think investment per se is a problem. This is something that we saw again at our research park, at our incubation. Focus will be to start with those who can afford and ready to invest. And remember, they are the ones who are also contributing to the most. So I'm not trying to make them feel guilty, but they will get return on investment. Government's roles will be to manage change, and I'll come towards the end. Of course, a little bit of other things. Now, this is therefore what we did. We did exercise. What can be reached return on investment scale? We are not talking about technology not being ready, but what will reach ROI stage? In 5 years, 10 years, and 15 years. For example, solar, wind, wheeling of energy, grid storage, energy efficiency, transmission and distribution, hydroelectric storage, electric vehicles, two-wheeler, three-wheeler, energy management system. All this is already there. Already you will see next generation solar cell, Milind will get it. We'll see it will start somewhere here. It may take us 6-7 years before we can get to the next generation, but doesn't matter. Electrification of construction equipment, it really has a return on investment starting today, may spill over to 7 years, 8 years. Electrification of agricultural equipment is another thing that we really need to do, and this is what we need to do. 5 to 10 years. Long-term storage. I'll talk about short-term and long-term storage. Ocean wave and tidal energy. We are not there. Larger EVs and freight transportation. We can get there in 5-6 years. 6 years. Green hydrogen. For ammonia production. Green hydrogen for cement production. Green hydrogen for iron and steel production. In 5 years' time, we'll be knocking $1.50 or something like that. It is at that time your ROI can start seeing. I'm not saying technology is not there. Technology is there today. But it's not at a stage where we can get to $1.50, $7. Similarly, carbon capture is there today. But I think it will take 6-7 years before it will have a ROI. After that, it doesn't require support. Remember that. Today, you will require R&D money. In fact, a lot of R&D money should go into carbon capture. But probably 6-7 years onwards. And this work will go on after that. It is not, sequestration will not be over for the next 15 years. There are only a few things. Smaller modular nuclear reactor, we really don't know as much. We have a very nice speaker on day 3. In fact, I had a lot of difficulty in getting people to come for that area. We need to open up that area because that will also play a role. Compressed air storage, again, something that we don't fully understand. So green electricity in India. Technology has reached ROI. For example, solar and wind, 2 rupees to 2 rupees 50. It is slightly getting higher, 275 and all that this year. Hopefully, work of Sujoy and Milind will bring it back to below 250. It's lower than the cost of putting a new plant of coal with pollution control equipment. If you don't put pollution control equipment, coal is still cheap. Once you put pollution control equipment, coal is not cheaper. Oil gas is very expensive. These numbers should have been revised. In fact, with oil gas price going up, whenever we turn on our diesel generator, we pay 32 rupees per kilowatt hour. That's the cost. And so this is what's happening. What stops India from converting renewables? Because this is not 24/7. We have large plans to set up 500 plus gigawatt, and it is on track to some extent. But installed capacity is 27%, but total energy that we produce from solar and wind is only about 9%. The reason is not 24/7. And without the storage, we are not going to get anywhere. So energy storage plays an extremely important role, and it is becoming economically viable. We will prove this here in the research part. What does the storage cost? Now, very often, since there are a lot of youngsters out here, they don't know. It's a capital cost. How do you really convert the capital cost to per kilowatt hour cost? Actually, you need to understand the capital cost. How many times can it be used? Charge, discharge, number of cycles, usage cost per cycle, what is operation cost, how many cycles of battery charge, discharge can be done in a day. Or else, why is that important? You'll see that interest cost plays a very, very important role. So whether that battery will last for 3 years or 6 years will determine the per kilowatt hour cost. And whether it is 1.5 times or 1 time. Storage without decay, leakage, end-to-end energy efficiency, you have to work it out. And with this, you can calculate the cost. In fact, in courses that we teach this thing. Cost per kilowatt hour of something which is purchased one time. And then use that to compute. For example, I have taken 2 cells, one advanced NMC cell costing in India, full battery costing 20,000 rupees per kilowatt hour, 7,000 cycles. This is not a low cost NMC cell. And there's another one I took LTO. One can make cost lower, but 40,000 rupees, 15,000 cycles LTO. And what I did is that I actually plotted per kilowatt hour cost, taking everything into account, taking the interest rate, assuming 1 cycle used per day. Sometimes sun is out, you charge, use it in the night. And you see that interest cost dominates. The cost would have been 3 to 4 rupees per kilowatt hour. In Europe, where the interest rate is 1 or 2%, the cost is only this. Once it comes to 10% interest rate, I'm not even counting 12 to 14%, Our interest rate is again rising. Cost is going up to 7 rupees. And in the LTO cost, it is about 12 rupees. In fact, it is the interest cost which will rule out certain technology, because upfront cost is just too high and will support certain technology. Fortunately, if I am able to do 1.5 cycles using both wind and solar, my cost comes down. And I don't have to put all the electricity through storage. If you assume 70% can be used directly, only 30% needs to go through the storage. My average cost comes down. And today, including wheeling cost, including everything else, today in this place, we are aiming at a cost close to 7.25 rupees per kilowatt hour. With 24/7, not looking at the banking by the grid. Because banking by the grid is somebody else paying for the storage. Today, we may, in a small way, if you are doing small amount, we can handle it. But if India do it at a large scale, where will the grid? Somebody has to pay for the cost. That's a kind of cost. And that cost can hopefully come down to 7 rupees. But remember, today we pay 11 rupees per kilowatt hour otherwise. So, total thermal storage cost on the other hand. The other interesting thing is, we are using so much of air conditioning? So, can I use chilled water storage? And 40% of energy in this place is used for heating, ventilation and air conditioning, and we are able to store chilled water at 6 degrees centigrade. We'll send you these slides if you want tomorrow, and that cost comes out to be much, much less. This is what we are able to do quite well. And we can do a similar kind of systems for housing. Heating and cooling will play a very important role, and storage will play an important role. How much storage is required? We try to do a calculation for a research park. So what is the number of megawatt hour that we will require? We took that 50 kilowatt hour, 50 megawatt hour is what, we use per day. 50 megawatt hour used per day. We use that and 50,000 units, and then we calculated the solar, wind, and we are able to figure out how can lithium ion and chilled water storage can give us more or less 24/7. And we figured out that if we have 15 megawatt hour of storage totally, we'll be able to do that. And this can be done for any enterprise, this kind of computation. But what about long-term storage? The problem is, wind, for example, is very, very good for 4 or 5 months. And then goes down. Sun is more or less constant. We need long-term storage. Neither the chilled water storage nor the lithium-ion storage is any good. That's where alternative technology is required. And fortunately, some very, very good work is getting done out here. Need storage for several months. And chilled lithium-ion battery, and this does not work out to be economical. So what we are trying to do at IIT Madras Research Park, we recognize that 65% of electricity today is consumed by commercial sector, industries, and high-income group housing. This is what the India's number is. It's going up. And they pay between 8.50 to 12 rupees. Today, with the recent rise in tariff in Tamil Nadu, it is closer to 12 rupees per kilowatt hour, including the diesel generator cost that we do. And so this is what we have to beat with solar. And this is what we can do, solar and wind. And can we get to 7 rupees per kilowatt hour with everything inclusive? And this is assuming that you have to do the storage. And this is what we are trying to do. So we have 1.2 million. We consume 50 megawatt hour power per day. We pay not 10, now 10 was till about a month back. Now it's more like 11 rupees. And we today are aiming, and our board has just cleared the proposal of buying solar and wind. And we will put storage out here, including that we will aim to get it lower. Now this can become a model. If we can do it here, we can do it in any other place. And we can then go to the industry and high income group housing. That's what we are trying to do. And of course, at the same time, we are working on chilled water storage. We have a wonderful chilled water storage. Tomorrow there will be a tour of Research Park late in the afternoon. We will show you all these facilities. And the interesting thing this afternoon we'll discuss is combined heating and cooling systems to increase coefficient of performance. Extremely critical. This is the key technology where we have to really win. And can I use chilled water for cooling and hot water to canteen? Chilled water storage with hydrates, another area that some of our colleagues are working. PCM hot water based storage with wax. These are things that will get us results in next 3 to 4 years. This is within the 5 years. If you look at our usage, this is a IIT Madras Research Park usage, and you see that it peaks during certain time, and we are looking at, even if you do peak shaving, we pay what is called demand charges in India. And demand charges actually adds very significant to per kilowatt hour cost if I don't use electricity 24/7. We don't use, we primarily use in the daytime. So by just doing peak shaving, we are able to significantly reduce our cost. And that's the first use of storage that can be done. And we really need to do extremely good energy management system for doing something like this. When to charge, when to discharge the storage. Zinc air battery, as I told you, is something that we are betting upon. We are fairly confident that in about 5 years' time, we can do long-term storage. And it will I'm talking about ROI. I'm talking about something which can be scaled up. Zinc air, and there are other similar kind of batteries which we can, I wanted to work on sodium batteries, another something that we can really, one of the big problems is sometimes when we don't understand the economics. One of the things that I found, the round trip efficiency for something like this is very low. It's only 70%. 30% energy is wasted. So our first reaction was, what's the use of something like this? Lithium ion gives me 99%. Chilled water gives me close to 95, 96%. This is only 70%. Till I figured out, when the wind is at peak in July, actually I waste that wind energy. At that time, my cost of wind energy is ₹2.50. If the energy efficiency is 70%, just let's look at it that my cost of wind generating is ₹3.50. It's still so much better. And suddenly the long-term storage becomes very, very important. What I'm pointing out, understanding of economics and finance is so critical for R&D. Very often we have separated the two. And in fact, Research Park is one place where we combine the two. This is what has made the difference at IIT Madras Research Park, that we have really combined finance and economics along with technology. And that's what makes a difference. Aluminum air, iron air, all these could be a potential contribution. And what do we need to do? Electrify everything. And one of the very, very good figure that I got only 2 days back. See this latest figure. What is happening to the electrification of our vehicles? I remember 2016 when I went there, I fought all the 8-9 departments in Delhi to try to get a policy and get electrification moving. And such a large lobby against it. And for long, people kept on saying nothing will happen, nothing will happen, nothing will happen. And then you suddenly see 19, 20, 21, and you suddenly see 22, FY22. Then you see FY23 in the first 9 months. And then I saw the numbers in the last 3 months. We are already 6%, 4%, 5%, 6% last month of the total vehicles are electric. Next year, by this time, we will be 15%, 20%. The year after, probably 25, 30%. Electrification of vehicle is already here. Two-wheeler, three-wheeler, it will start, others will happen. Electrification of construction, agricultural equipment has to be actually done. Green hydrogen, very, very important. Making green hydrogen as close to $1 per kg. We have some startups out here, we have some companies out here which are focused on something like this. Even if we get to $1.50, even if we get below $2, it's something that will make a difference. Even below $2. And that's what we really need to do. And we have to look at green hydrogen is not so much for vehicles as in the beginning. What will make most sense is ammonia production, aluminum production, steel manufacturing, cement manufacturing. This is the areas that we can start pushing things. This is the area that we really, really feel that a lot can be actually done. This, I think, in 5 to 6 years we'll come close to this. And work on how to use green hydrogen for ammonia, aluminum, steel, cement needs to start happening today. Similarly, decarbonization of cement manufacturing, a major area. As GDP increases, we'll build more and more. We'll be the largest building. China used to be building the most. India will become the one which will be building most. And it's a huge emitter of GHG emission. And 35% of carbon dioxide due to fossil fuel used in cancellation, and 65% is emitted closer to the building when we convert it into concrete. We need to understand every aspect of the technology. And what do? Concrete manufacturing, we have to build it closer to construction site, some kind of prefab, where we capture carbon dioxide and sequester it in the pillars and in the walls. That is what we will require. That kind of technology will require. Now, if you do it in pillars today, one of the problem is pillars use so much of iron that immediately that carbon dioxide will rust the iron and the pillar will lose the strength. And therefore, we have to start working on how to replace that steel in a structure by glass fiber or by something like glass fiber or other carbon fibers. That's what we really need to do. And this is something, again, this will take a little bit of time. This is what I was saying may go to 7 years, 8 years, 10 years before we get ROI. Technology is known, but to get ROI, it will take some time. Reimagining electricity grid, that I pointed out, 24/7. The best way is, can I put that together? Can we put our fights amongst each other out? Our biggest enemy of the climate change, overcoming climate change, is in fact that nations don't work together. Otherwise, there is no reason we can't have a grid all the way, at least from Singapore or Far East, Japan, to all the way till United Kingdom, and maybe even cross over the Pacific Ocean. That's what is required, and I really want one sun world, one world to actually succeed. And as I pointed out, an Australian company promises to underwater link between Singapore and we must learn that, and we must understand how to get there. Likely bottlenecks, I want to point out that one of the bottlenecks will come is recently we invested so much in coal. All the coal plants, money is sitting there. They have not depreciated. Their interests have not been paid. They will be a big opposition to any change. All the coal mining. And the coal mining is in the eastern, northeastern sectors, the states which are lower income states. You try to say shut down these minings, what will happen to the employment? What will happen to the investments that have gone in? 5 years back, we did the huge, very high cost auctions. What is going to happen? Similarly, the auto industry, oil sector, or Maharatnas, what will happen to them? And this is the biggest challenge the government will have to face. I don't think technology is the only concern. Technology is what we can do. But government's role should be less in technology. They should not try to select this versus that. They can provide some funding. The rest of the funding can be obtained from somewhere else. Their role should be the managing change. Transition requires change management. Change management, ensuring that our GDP and employment is not affected. Ensuring that some states do not suffer. And this is the challenge. This should be the prime role of the government. Very often government tries to do the first and we try to do the second. We mess up both. This is what I am trying to say we need to change. Sum up. India and the world needs to move towards net zero. There's no, and only way I know is take R&D to return on investment, and we can do that. And I think we have enough scientists and technologists. Whatever we don't have, we can borrow from anywhere in the world. We learn from anywhere in the world. We can actually do this. It's very strong. But before I end, one last slide. Something that I pulled out only this morning, I think. What is happening to the energy usage in the world? And see what has happened. This is what the energy usage has gone up. And we are going up and up. If we continue to do that, can technology save us? Frankly speaking, no. Are we, by doing this, are we getting much better life? We cannot follow the path that has been set by the West, where we consume more. That path is a path to disaster. I will go back to what Murugappan had said and what Gandhiji had said. There's enough in the world for everyone, but not enough for everybody's greed. And I think this is, while we fight, do the technology, develop the technology, we also have to adopt simpler living. Of course, living with comfort, but simpler, comfortable living is what we really have to evolve. And that's where all the thinkers, social scientists, everybody has to come in. We cannot follow the path where we consume more and keep rising. Remember, this is happening with 60-70% of the people in the world having very low per capita GDP or energy consumption. What happens if they rise? And this is what we need to stop. Thank you very much.